I want you to take a minute and just look at this triangle. How could you use law of sines to solve this triangle? It's not a right triangle, it's an oblique triangle, so we can't use regular trig. We could only use, all we know right now is law of sines. But the law of sines, you have to put the side over the opposite sine of that angle equals a side over, again, the opposite angle there, the sine of that opposite angle. But we don't know. We know these two sides, but we don't know these angles. So this is considered a what? What kind of triangle? Side, angle, side. So this is a side, I'll just put it right here, angle, side. Could we use the law of sines for this triangle? We don't even know any of the angles. So there's no way to use law of sines. This is just a side, side, side. So if you get two triangles and you know a side, angle, side, or a side, 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 you can't use the law of sines to solve it. So guess what we learned today? Law of cosines. Da, 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 da. Backing up, backing up, backing up. Dun, 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 dun. All right, so law of cosines is a little bit more. Let me write one real quick. A squared, so the side, equals B squared plus C squared minus 2BC cosine of angle A. So if you'll kind of take a look at that pattern, this pattern extends for any side. If you wanted to change the letters, you could. Notice that whatever side you're solving for over here, you're going to use the opposite angle for cosine. It's the law of cosines. So if we wanted to find side B, we're going to have to use A squared plus C squared, the two that you don't have here. So A squared plus, C squared minus 2AC cosine, what side are you looking for here? B. So this angle B. And then C squared follows the same pattern. So if you have C here, you've got to have A and B here. So A squared plus B squared minus 2AB cosine of angle C, the opposite angle from this side. So you can, it's basically, all it really is whatever side you're looking for. If you're looking for this side, you're going to square these two sides, add them together, and then subtract 2 times the two sides, multiply together. That was the square, by the way. I don't know if I said that or not. It's these two squared added together, minus 2, these two sides, and then of course times the cosine of whatever angle is opposite the front letter, okay? So that's the pattern, but it's called the law of cosine. So let's do an example. All right, here we go. So I'm going to give you, I'll tell you what, look, for this first we're going to do 2. And if you did print the blank notes, this was Roman numeral number 1, and this is going to be Roman numeral number 2. Okay, so this is A, B, C this time. And so little c is across right here. And B is 20. And we also know A, 26.5 units. We don't know if they're inches or whatever. And then the angle that is given to us is not that one. Oh, I'm sorry. I said it wrong. I want to be consistent with the notes that's in Google Classroom. So it was actually C that was given. So then this was right. Okay. So what you've got to kind of pay attention to is thinking about, quiz or a test. Well, we won't have a test in this, but we'll have a quiz. So thinking about it, what you would have to notice when you've got this problem, okay, you got a side, an angle, a side. So that is an SAS. SAS, you cannot use law of sines. The only way to solve it is using the law of cosines to get started. You can use the law of sines after you get some information. See daisies? Can't drop these. We gotta remember this. Wash your hands. Wear your mask. Okay? All right, here we go. So we know these two sides, so the only side that we don't know is A. So that's how we'll start with this top formula right here. So A squared equals B squared plus C squared minus 2 times BC, so 2 times 20 times 30 times the cosine of that included angle. Okay, and then you're just going to put this in your calculator. Somebody's calling.
Private.
So that's 400
Call from private.
plus 900 minus 2 times 20 would be 40. 40 times 30 would be 1200. That doesn't look like a 2. Try that again. Cosine of 60. What is the cosine of 60? You should know that. 60 degrees. You should know that. 1/2. Anyway, so you finish it out, you'll get 700. Now, this is not A, it's A squared. So you have to square root both sides. And I think your book is having you round to the nearest 10th.
Call from private.
So it's approximately 26.5.
Call from private.
So A, approximately 26.5. Well, we're not finished. To solve a triangle, you have to find all 3 sides and all 3 angles. So we need to know what these two are. Well, the truth is you could use the law of cosines, but as you've probably seen, the law of sines, as you remember from the last couple of days, law of sines is actually a little bit easier. It's a little bit easier. So I would just use the law of sines. So if we're going to use the law of sines, we were given, well, let's just find B, okay? So 20 over the sine of angle B, and we're going to have to use this. Now, oops, sorry. The angle 60, so the sine of 60, we on the bottom. And the side opposite. Okay, now I got some good advice for you. You technically could use 26.5, but you rounded that off. It's not exact. So what you might want to do is go back and use the exact. Radical 700, that's exact. So you can use your cross products. So we've got radical 700 times the sine of B equals 20 times the sine of 60 degrees. Divide both sides by radical 700. Ching! Now, the measure of B, how can we do that? It says the sine of measure of angle B is this. So how can I actually get the B? Hopefully you remember inverse sine. So you're going to do the inverse of this. That will give you the B. And your book is having you round to the nearest whole number. So when you actually enter that in, you will get approximately 41 degrees. So rounding to the nearest whole number, and then you can add these two together. That'd be 101, right? Yep, 101 degrees. Subtract, so that would leave you 79. So solving it, you get your 3, okay? Now there is an extra example if you're interested in it. There's an extra example in your notes that are in Google Classroom. But I want to take a minute because we have to actually do this in a very specific order. And I didn't mention it, but at the bottom, if you printed it, it's at the bottom. We're going to write down the strategies. Okay, and I want you to think about why. Okay, so the first thing you're going to do, use the law of cosines. To find the side opposite the given angle. Use the law of cosines to find the side opposite the given angle. And you kind of don't really have a choice because if you're given the included angle, then these are the two sides. This is an SAS. So you kind of are stuck. That's about the only thing you can do, okay? So remember, this is the strategies for an SAS. All right, number 2. Then you're going to use the law of sines. Now, this is the important part. To find the opposite angle of the smaller side. So 20 is less than 30. This is the smaller side between these two. We found that one already. So B is what we needed to find. And I didn't mention it, but I'm telling you now. Now, why? Use the law of sines to find the angle opposite the smallest side. That's very important. So why do you think, I want you to think about it for a second, why do you think it matters? Okay, we have to remember something about inverse sine. Remember that the answers are restricted and they are from negative, I'm just going to use degrees since we're doing triangles, from negative 90 degrees to positive 90 degrees. So if you use a larger angle and it was actually more than 90 degrees, you would get you would get an error. You would not get an answer. It's impossible. You can only do inverse sine from negative pi over 2 to positive pi over 2, or negative 90 degrees to positive 90 degrees. So you're always going to have to find the smallest side first. That'll safeguard you. That'll take care of you. And then you can just add the other those two angles and subtract from 180. And of course, the last thing is to do that. Find the last angle by subtracting the sum of the two angles, the two known angles, and I know you know this, from 180 degrees because of the good old triangle sum. Good old triangle sum theorem that you learned in geometry. Doesn't matter what your triangle looks like, the three angles add up to 180, okay? All right, so this is how you attack and solve an SAS. So the other thing we need to look at is how do you attack and solve an SSS. All right, so I'm going to erase this and we'll start. This is actually Roman numeral 3. So I'm going to leave that up there, and then when we do the SSS, you'll see how you need to approach it. So this is Roman numeral number 3, and this is solving an SSS. That's what this one is going to be doing, okay? All righty. Roman numeral number 3, let me give you a triangle. All right, 6 units. Side C is 4 units. So what kind of triangle is this? Side, side, side. SSS. So we can't use the law of cosines to find the side opposite. Find the side opposite the given. I think I forgot to write the word angle over here. Because there's only one given angle in an SAS, side, angle, side. Okay, so side, side, side. How do we attack that? All right, so number 1, the first thing we do is use the law of cosines. I could have left that, but oh well. Use the law of cosines to find the largest angle. Now I want you to think about that. Why do you think we need to find the largest one first? Well, if you try to find another one, you actually can end up with some wrong answers. But if you find the largest angle first, you're going to be good to go. Now think about, we're going to end up doing inverse cosine to get the angle. We're going to use the law of cosines. We are going to use the law of cosines, but we're going to find an angle this time. Well, think about inverse cosine. What's the the restricted area? What's the only answers you can get? Well, hopefully you remember it's from 0 to pi. Those are the only answers your calculator will give you. So if you go ahead and find the largest one, everything else is pretty much going to work out. Because if you do the first one between 0 and pi, or 0 and 180 degrees, if it turns out to be 120, you got the big one out of the way. It's taken care of. So you always need to find the largest first. Well, then you might look and say, well, which one's the largest? Well, hopefully you'll remember that. Let's see, 4 is the smallest. So that means C is the smallest angle. A is 6, that's the middle side. So that's the middle angle. And then your largest side is 9. That means B is your largest angle. So we're going to need to find angle B first. Well, if we're going to if we need to know angle B first, we're going to use that formula right there, okay? All right, here we go. So B squared, 9 squared equals A squared and C squared minus 2 times A and C times the cosine of the largest angle, B. Now, this is a little bit more complicated to solve. You know, you're not just doing all that in your calculator. You're actually having to find this. So just be a little bit careful. 81, 36, 16 minus 24 times 2, 48 cosine B. All right, then you're going to have to add these two together. You cannot subtract the 48 because it's not just the number 48. It's actually minus 48 times the cosine of B. So you're just going to have to add these two first. So 52 minus 48 cosine of B. Then we'll subtract the 52. So that would be 29. Then divide by negative 48. So negative 29 over 48. And then to find the actual B, you're going to do the inverse of cosine of this. So we're going to do, to get B, we need to do the inverse of the answer. Remember how it works? Inverses mean the domain and the range switch. X and Y switch. Input and output switch. So we're going to switch it and get the value. Now, before we actually put that in our calculator, I want you to think about it. With that angle being quadrant 1, quadrant 2, thinking of the unit circle. It's negative. Could it be in 1? No. Everything's positive in 1. So it's in quadrant 2, which means it's actually greater than 90. It's between 90 degrees and 180. So put that in your calculator, do it, and you'll find out it's approximately 127 degrees. And your, like I said, your book is having you round the angles to the nearest whole number. All right, so angle B, you can see it is an obtuse angle. So that's 127 degrees. So there's one answer. We need to get the other 2. Now to get the other 2, we can use a law of sines. And it really, now that you've taken care of the fact that if it was obtuse, you've gotten it. If it wasn't, it's okay. It won't matter. But you can go ahead and, pick another one. So I'll just go ahead and I'll do this one. So 6, and I'm going to use law of sines. So we're actually over here, if you're taking down these notes, you're going to use the law of sines to find another angle. And technically you could use law of cosines, it's just law of sines is easier. Alrighty. So 6 is to the cosine of A as B, 9 is to the cosine of 127. And what you might want to do here is rather than use the rounded, oh, I'm sorry. What am I doing here? I put cosine. Yeah, this is a law of sines. Sorry about that. Thank you. Good thing you were here, Dorian, or I would have messed that up. Or was that Lucas told me that? Somebody told me that. All right, here we go. So back to this though. When you use your calculator, I had my calculator. I don't know what I did with it, but anyway, what you probably really want to do is go back to your calculator and look at it. Take it out about 3 or 4 decimal places. That way you know you'll get the right answer. Okay. All right, doing the cross products. 9 sine A equals 6 sine 127 degrees. Divide by 9. So A is approximately the inverse sine of 6 sine 127 degrees over 9. So you'll just pop that in your calculator and you should get about 32. Then number 3 is the same on your strategies. Just add these 2 together and subtract from 180. And I have done that and it's 21 degrees. Let's make sure that's right. That would be 159, yeah, 21 degrees. Alrighty, so you've learned the law of cosines. You've got 3 versions of it. And you've also learned that you really need the law of cosines because that's the only thing you can do to attack a side angle side and a side triangle. And then you can also, after you get that first step, then you can go on and use the law of sines because it's a little bit shorter, a little bit easier. So, all right, good job. Let's keep working hard.